We have a couple more things to look at, and that's our growth and decay formulas in this section, okay? So we're going to talk about exponential growth as labeled as this function, y equals a times 1 plus r raised to the t power, and our exponential decay as y equals a times 1 minus r raised to the t power, where each of these are represented like this. Our y is your final amount, the a is your initial amount, the r is your rate as a decimal, and the t is your time, okay? So the first thing I want to talk about is rate over here. If it tells you that something increases at an interest of 5%, if that rate is made as a decimal, that decimal is going to be 0.05. So your decimal right now is here, and you've got to move that 2 places back to create your 0.05, okay? So if I had, say, 15%, then it would be a 0.15, okay? All right, just want to go over that, make sure you understand it. So let's look at a problem. You put $1,000 into a college savings account for 4 years. The account pays 5% interest annually. How much will you have at the end of 4 years? Now, hopefully you realize that if you're putting $1,000 in and they're going to pay you interest, that means that's going to represent a growth. So that means we're going to use this function here. Y equals a times 1 plus r to the t. So let's see what each of these represent. Y equals final amount. Well, that's what I'm looking for. How much will you have at the end of 4 years? So that's what I'm looking for. Y equals. All right. A is the initial amount. How much did I initially put in? I put in $1,000. So that is 1,000. I don't do anything with the 1. Plus the R is my rate as a decimal. My rate here is 5%, so that means I'm going to use 0.05. And then my T is the time, so it tells me how much will you have at the end of 4 years. So I'm going to put a 4 up here. Okay, at this point, it becomes a calculator problem, guys. So we're going to go to our calculator, and we're going to key in 1,000 times 1 plus 0.05 raised to the 4th power. Okay, we get $1,215, and I'm going to round to 51 cents because that's 506, so it'd be 51 cents. And that would be our answer. Okay, let's do another example. You invested $2,000 in a savings account at the end of 6th grade. The account pays 4% annual interest. How much money will be in the account after 6 years? Okay, so again, I'm growing something. They pay me interest, so that I'm going to use this growth formula. So same one, y equals a times 1 plus r to the t. All right, y is what I'm looking for. My initial investment A is $2,000. 1 plus my rate is 4%, so that's going to be 0.04. And then T, my time in years, is going to be to the 6 because I'm looking for after 6 years. Okay, so we're going to come to our calculator and we're going to key that in. 2,000 times 1 plus 0.04 raised to the 6th power. Okay, that gives us $2,530.64 because it's 638. So we're going to round to 64 cents. So we get y equals $2,530.64. Okay, pause the video here and try this next example, and then come back and I'll work it. Okay, so hopefully you've worked this. We invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years? So we're still going to use y equals a times 1 plus r to the t. Okay, so y is what I'm looking for. A is $500. That's my initial investment. 1 plus my rate is 3.5. So hopefully you realize that that's 0.035. And my T time is after 5 years. Okay, if we key that in, I'm going to put it over here so you can see it. 500 times 1 plus 0.035 raised to the 5th power. Okay, $593.84, because that's a 3, so that's going to be 84. So 593.84. So 593.84. Okay, those represent our exponential growth. If you have any questions, let me know.